If you want to stop and try the others on your own and then check back and make sure you did those right, you can totally do that, or you can watch as I do these. Okay, so I'm going to do c of x. Okay, so c prime of x equals, I'm going to move my 2 down, so I'm going to do that in blue, times what I started with, which was 3x squared, and now I take away 1 from the exponent. Okay, there's another term, so my exponent is 1, so I'm going to drop that forward. So I'm going to say plus 1 times what I already had, which is 8x to the 1. And because I'm doing the derivative, I have to take 1 away from the exponent. So what you should notice, okay, is that this matches this, and this matches this. And then I have minus 1. So if I really wanted to, I would need to say negative 1 times x to the power of 0. Well, the power of 0. Well, that means I'm going to have to say, actually I'm going to write this down. It's like x to the power of 0. So, let me go back here. Just erased what I wrote. So this is like x to the power of 0. So basically, I'm going to kick 0 forward and say minus 0 times 1 x to the 0 power minus 1. Okay, so let's go ahead and simplify. So we have 2 times 3 is 6, x, plus 1 times 8 is 8, x to the 1 minus 1 power is x to the 0. X to the 0 is 1. So we just have 8 times 1, which is 8. And now we have 0 times some stuff. 0 times anything is 0. So our derivative for c of x is 6x plus 8. So hopefully you notice that whenever I have just a term without an x value, a constant, it goes away because it's essentially, we're multiplying it by 0. So if we look down here, what's going to happen to 11 in our derivative? If you said it's not going to be there, you are absolutely right, because it goes away because it's like multiplying it by 0. So I'm going to do this one without changing colors. So I'm going to drop 2 out front, times it by what's already there, and take my exponent and take away 1. So I end up with d prime of x equals negative 6x. So there we go. So we only have one other thing to do. So what we're going to do is we're going to now find the gradient of each function at a given x value. So these are what we found on the screen before I just wrote those. So we started with a of x and we ended up with a prime of x, b of x, b prime of x, c of x, and so on. Okay, so we started here to use differentiation and ended up here. So at this point, I'm not going to do anything with these, so I'm going to trash them, and I don't need this fancy little arrow. So I'm going to move this over. So basically, I want to find the slope of a prime of x when x equals 2. So all I'm going to do is I'm going to say a prime of, what are we putting in for x? We're putting in 2, so I substitute 2 everywhere I see x. If you remember with function notation, this just helps us organize a little better. That equals 20 times 2, because that's what I substitute for x. So basically what this says is when I use the derivative of a of x, and I substituted 2 for x, the slope of my tangent line was, whoa, 40. That's a huge slope, okay? So basically we rise up 40 and run 1. Rise 40, run 1, okay? So the slope of my derivative at x equals 2 is 40. Alright, let's do b of x now, b prime of x. So now I'm going to be using negative 3. So everywhere I see x, I'm subbing in negative 3. So this is going to give me my slope when my curve has an x value of negative 3. So everywhere I see x, plugging in negative 3. Okay, so I use this and plugged in negative 3 here. So I end up with 24 minus 3. So the slope of my tangent line when x equals negative 3 is 21. Boy, I definitely have a knack for large slopes here. All right. Okay, if you want to try the next two on your own, go ahead and pause and then come back and make sure you do it right. But you should have all these examples in your notes. Okay, as usual. So c of x, I'm finding the slope when x equals 0. So I'm going to say c of 0 equals 6 times 0 plus 8. So c prime of 0 equals 8. That means when on my original function, when x is 0, the slope of my tangent line is 8. Okay, not as steep as the others. Alright, and finally, moving on to d prime of x. I am finding my slope when x equals 5. I certainly picked large numbers here. Equals negative 6. Everywhere I see x, I'm putting in 5. So basically, on my curve, when I substitute 5 in, I'm looking at the point where x equals 5. My slope of my tangent is negative 30. So this is our first negative slope. Okay. So, I forget what my original function looked like, so I'm just going to sketch this out for us. It was 3x, or negative 3x squared plus 11, so hopefully you remember that. The negative turns this upside down. We're up 11 units, like this, and it's skinnier than the normal parabola. Okay, so what this says is that when x equals 5, okay, our slope is negative 30 of our tangent. So if this is like, so if this is negative 5 down here, what this is saying is the tangent at, oops, yeah, I'm not doing this very well. The tangent at this point has a, looks like a positive slope. Let me try this again. One more time. Okay, maybe one more time after that. Okay. Okay, that's a very crummy drawing, but what we're looking at is the slope is negative 30. So it's a really steep negative slope when x equals negative 5 on our original curve. Okay? Alright, so that is how you find the derivative at a given x value after you differentiate it. So that is all we're going to do today, so make sure that you have these down in your notes and be ready to take a survey as well as participate in a discussion board as soon as we get into class on Monday. Alright, enjoy the rest of your weekend.